Hello guys, hope you will be fine and taking good care of your health. Welcome to this video. In this video we are discussing a topic of physics, that is force and the momentum, and this is at page number 67, page number 67, page number 67. Open your books and underline the important lines or important defines. Consider a body of mass m and moving with initial velocity vi. You know that a body having mass m, when it start moving, then this velocity is called its initial velocity. Let a force act on the body, producing an acceleration a in it. So when you know that when force act on our body, then it produces acceleration that we learned in Newton's second law. This changing the velocity of a body. Of course, when a force act on a body, then its velocity will be changed from initial to final velocity after time t and become vf. You know that the formula of momentum is P is equal to product of mass and velocity. We already learned P is equal to mv. Momentum is denoted by P and its formula is P is equal to mv. So if you can see V is involving here. If velocity is changing from Vi to Vf, its momentum is also changed. The momentum for initial velocity means mvi is called initial momentum pi. So here I write, if pi and pf are the initial momentum and the final momentum of a body related to initial and final velocities respectively, then of course the formula of momentum is P is equal to mv, and velocity is changing from initial to final, then its momentum is also changed from initial to final. So again I write its mathematical form. First of all, here I write the formula of momentum. You know that the formula of momentum is P is equal to mv, as here we are taking initial and final momentum because velocity is changing. When velocity change, its momentum is also changed. So that's why here I write here I write its mathematical form. Initial momentum will be equal to mvi. For initial velocity we say initial momentum, for final velocity we say this is final momentum. Pf is equal to mvf. You can see here momentum is changing from initial to final. So now means momentum is changing, so I write here change in momentum. Change in momentum. So change in momentum will be equal to Pf minus Pi. Change in momentum is equal to, here I write Pf minus Pi. Now I am putting the value of Pf and Pi. The value of Pf is mvf and the value of Pi is mvi. So I am putting here mvf minus mvi. On the right side you can see m is common, so I am taking m common. Here I take vf minus vi is equal to Pf minus Pi. Remember one thing more, we are discussing the relation between force and the momentum. here you can see our topic is force and the momentum. So again, when we take rate of change of velocity, that is called acceleration. How we can take acceleration? Acceleration is equal to rate of change of velocity vf minus vi over t. That is called acceleration. So if we want to rate of change of momentum, that will be equal to rate of change of momentum, we divide it with t. So now I want to take rate of change of momentum. So here I write rate of change of momentum, मीन मोमेंटम किस टाइम के लिहाज से चेंज हो रहा है, रेट ऑफ चेंज ऑफ मोमेंटम. That will be equal to pf minus pi divided by t, that is equal to mvf minus vi divided by t. I am dividing t on both sides because I want to take rate of change of momentum, means how much time take to change this momentum. मैं ये momentum का rate of change of momentum लेना चाह रहा था, तो मैं t से इसको क्या करूँगा, बोथ साइड पर डिवाइड कर दूंगा. ऐसा नहीं है कि मैं वन साइड पर डिवाइड करूँगा, क्योंकि मैं तो रेट ऑफ चेंज ऑफ मोमेंटम लेना है, तो मैं इसे फर्स्ट लेफ्ट साइड से डिवाइड करूँगा, राइट से नहीं करूँगा. ऐसा नहीं है, मुझे बोथ साइड से इसको क्या करना होगा, डिवाइड करना होगा. So now you know that the rate of change of velocity vf minus vi over t, I underline this, rate of change of velocity with respect to time. I write a formula here, that will be equal to a, vf minus vi over t is equal to a. So I am putting the value of vf minus vi over t here. When I put the value here, I get pf minus pi over t, that will be equal to ma. I am putting the value of vf minus vi over t, that will be equal to a. So here I put here a. Okay, now from Newton's second law, you know that what is Newton's second law? You remember Newton's second law is, I write here Newton's second law. Newton's second law. Newton's second law is F is equal to ma. Now I am putting the value of ma here. I make a box here. I am putting the value of ma, that is equal to F here. So here I get pf minus pi divided by t is equal to F. So this is the relation between force and momentum. Okay, so you know that from topic we want to find the relation between force and the momentum. So here you can see we find the relation between force and momentum. This is momentum on the left side, and there is a force on the right side. So this is the required relation of force and momentum. So define is, when a force acts on a body, here when a force acts on a body, it produces an acceleration in the body and will be equal to the rate of change of momentum of the body. Okay, so when a force acts on a body, it produces an acceleration in the body and will be equal to the rate of change of momentum of the body. Again, when a force acts on a body means आपको जब भी वेलोसिटी चेंज करनी होगी इनिशियल टू फाइनल, you must apply a force on it. So when a force acts on a body, it produces an acceleration. Of course, when a force is acting on a body, acceleration is produced in their body and will be equal to the rate of change of momentum. Of course, जब आपके पास वो force आप apply करोगे तो उसमें क्या होगा, वेलोसिटी उसकी चेंज होगी, और वेलोसिटी जब चेंज होगी तो उसमें एक्सेलरेशन प्रोड्यूस होगा, बिकॉज एक्सेलरेशन इज रेट ऑफ चेंज ऑफ वेलोसिटी, एंड वो किसके इक्वल होगा आपके पास, यहाँ पर आप देख सकते हैं ये होगा आपके पास पी एफ माइनस पी आई ओवर टी के इक्वल. Of course, I hope you understand this topic. If you have any problem, you can ask me. Love you.